3.6, parametric functions. What a parametric function is? It is a pair of continuous functions that define x and y coordinates of a point in the coordinate plane in terms of a third variable. We usually use t. That is called the parameter. What I have here, I have -3 is less than t is less than 3. And I have this parametric function. X of t equals 2t minus 1, y of t equals -t plus 2. Then I have this chart. So I'm going to put -3, -2, -1, 0, 1, 2, 3. Copy this in the chart down. What you're going to do is we have our t values. You're going to substitute into the x function. So I put in -3. What's 2 times -3? -6 minus 1, -7. Now I do the exact same number into the y function. So I have -3 or -3. So it's 3 plus 2, which is 5. Right. I now do -2. Substitute in the -2. 2 times -2 is -4 minus 1 is -5. Put in the 2. -2 is +2 plus 2 is 4. Put in the 1, the -1. 2 times -1 is -2 minus 1 is -3. -1 plus 2 is 3. What's my pattern? It's going down by 2, or up by 2. So this one's -1, +1, 3, and 5. And this one's going to be 2, 1, 0, -1. Right. Well, not necessarily. I'll get to it. All right? Unless I say graph it, that's what you do. Why does this go up by 2? Because of the slope is 2x. The reason why this goes down 1, because it's -t. What I want you to do, just make a little tiny graph, or just a basic graph right next to the chart. You're graphing the xy values. The t gets me the xy. So my first point is -7, 5, which means -7, 5. I want you to plot the rest of that chart and see what happens. Graph all my points. The next one is 3, 4, right? Then it's like this. Right? 3, 0, and then 5, -1. It makes a straight line. Correct? Now, okay, my line's a little bit crooked. There, that looks almost better. We want to find the equation of this line, the line that passes through here. So I want y equals, what can I get right off the bat? What can I find? I can find the slope, so I just pick any of these points. I'll pick this one with this one. 1, 2, 1, 2, 3, 4. 2 over 4 is half, and it's going down, -1/2 x. I could have picked this point here and this point here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 6 over 12, still 1/2. And it crosses at, it's in between the 1 and the 2. So it's 1 1/2, so it's 3 halves. That's your equation. Right. Because it crosses the y-axis right here. And it's 1.5, and instead of writing 1.5, since I have a fraction, I just made it a fraction, 3/2. Let's look at the exact same problem, but I'm going to show you how to do it algebraically. This x of t just means x equals 2t minus 1. This means y equals negative t plus 2. What am I going to do? Okay. I'm going to end up substituting one into the other. So I need to rearrange one of these two. Which one do you want to rearrange? I want to rearrange for t. But which one do I want to use? The top one or the bottom one? Bottom. So I'm going to rearrange the bottom one for t. What's the first thing I have to do? Subtract 2. So y minus 2 equals negative t. Change the sign. So t equals negative y plus 2. I'm going to take this and put it into the top equation for t. X equals 2 times negative y plus 2 minus 1. All I did was use substitution method. Negative 2y plus 4 minus 1. Let's see, 4 minus 1 is negative 2y plus 3. Subtract my 3 over. X minus 3 equals negative 2y. Divide by negative 2. And you end up getting y equals negative 1/2 x. That's really a 1 here. Negative negative makes a positive 3/2. What do you notice? It's the equation that we had to go through and do all that extra work for. But you got to think, for this one, you got to make the chart, you got to substitute that number into both of them, then you have to graph, then you have to draw the line. No, I just showed you this is where it's coming from. Now, I could have rearranged it the other way. Instead of rearranging the bottom one for t, I could have rearranged the top one for t. If I rearrange this top one, what do I have to do first? I need to add 1 first. X plus 1 equals 2t. Divide by 2, 2, 2. T equals 1/2 x plus 1/2. I substitute this in for t and the y one. Y equals negative 1/2 x plus 1/2 plus 2. I distribute. Y equals negative 1/2 x minus 1/2 plus 2. Negative 1/2 plus 2. That's 1.5. Y equals negative 1/2 x plus 3/2. So it doesn't matter which one you rearrange for. You just substitute one into the other. Questions on how to do it graphically. Questions on how to do it algebraically. Algebraically, you're just going to rearrange one of them so it's t equals and put it into the other. We're using substitution method. It's like we have an x, y, and a z, sort of. But the z is going to cancel out in both ways. Let me show you an example of this. I'm going to need you to write this down. This way you have the actual problem in your notes. An outfielder throws a baseball to the catcher 120 feet away to prevent a runner from scoring. The ball is released 6 feet above the ground with a horizontal speed of 70 feet per second. and a vertical speed of 25 feet per second. The catcher holds his mitt 2 feet off the ground. The following parametric equations describe the path of the ball. X of t equals 70t, y of t equals 6 plus 25t minus 16t squared. Now, going through this problem, why is it 6 feet? If you think about this problem, yeah, he's releasing the ball 6 feet in the air. He's 120 feet from the catcher, 20 feet horizontally, or 70 feet horizontally. What is horizontal? Side to side. It's moving horizontally 70 feet per second. It's going in the air up vertically 25 feet per second. And the catcher's 2 feet, the glove is 2 feet off the ground. The catcher's squatting, he's ready to catch the ball. So horizontally, the function's x of t equals 70t. But for the vertically, what's this 6 from? It's where he released the ball. 25t, that's how fast he threw it. What's this negative 16t squared? If I throw something in the air, why? Why does it have to come back down? Gravity. That negative 16t squared is gravity. It's physics. All right. Take your calculator, second plus 712. If I go to put these in my calculator, because we want to find out, when does the ball reach its greatest altitude? What is altitude? Height. So I need to put this in the calculator. That's the best way to solve these. If I hit y equals, I can't put these equations in there. The reason why, I need an x of t and a y of t. Hit mode. You're used to graphing functions. This is a parametric function. So go down where it says function, go over to par, press enter. That changes it to parametric mode. Now hit y equals. The y equals now has x and a y. So you type in the equation for x, 70t. Now, you just hit the variable button next to the green alpha button. Usually when you type that button, hit x. Now it's a t. Hit enter. Now I put in the y equation. 6 plus 25 variable t minus 16t squared. That's my x equation. That's my y equation. When you hit zoom 6, you have this graph. It's kind of hard to picture what's happening. If you throw a ball, isn't it sort of going to go like this in the air? So I'm going to zoom out. Press enter. I don't see the full ball coming down yet. Press enter again. Now you see the ball getting thrown and coming down, but it's really a small area. I'm going to zoom, box. I'm going to box it in so I can see the graph. All I did was start the box in the corner. I'm going to box it in, press enter. So when you zoom, you have this. All right. We want to find out what this altitude is. What this highest point. This highest point, bless you. Second, trace. Never mind. I forgot when you change into parametric, it changes other things. Where does it look like it's the highest point? I'm just tracing it. The highest the ball ever reaches, it looks like it's about 15.7, actually 15.8 feet in the air. So the ball's almost 16 feet in the air. How far was the ball thrown? When it reaches its highest point, it was thrown about 55 feet horizontally. How much time has passed? Time has passed 0.78. So in less than a second, the ball is at its highest point. Right here? Hit trace. Now we want to know, does the catcher catch the ball? How high is the catcher from the ground? 2 feet. So he's got to catch it before it hits. So he's 120 feet away, right? Okay, here's 119, 128. At 119, how high is the ball off the ground? 2.2. Would he catch it? Yes. It's off a little bit, like maybe a couple inches, but that's about it. He would catch the ball. Your homework